Hi, so yeah, I'm here with Tristan and Stuart. We're here at RAL Space. Stuart, welcome to RAL Space. You work for Cohesion, and tell us a bit about you and what Cohesion does.
So my name's Stuart Coomber. I'm head of sales for Covesion, and Covesion is a company with more than 20 years of experience in the development and sale of wavelength converting products based on periodically poled lithium niobate. In this application we're converting 1560 nanometer source light into the 780 nanometer light that's needed to drive the Rubidium Atom Trap. The waveguide itself combines the nonlinear optical properties of periodically poled lithium niobate, which is a material with very high nonlinear optical coefficient, together with a ridge waveguide physical structure that confines and guides the overlapping optical waves. And it's this light confinement within the ridge that gives the waveguide a much higher conversion efficiency when compared to conventional bulk crystal nonlinear.
Hi, I am Tristan Valenzuela. I'm the head of the Quantum Sensors group here at RAL Space, and what we do is we aim to develop quantum sensors for space applications.
Could you explain a little bit more about what a Rubidium Atom Trap is?
Yeah, well, Rubidium Mod is a system by which you can confine and cool rubidium vapor, rubidium atoms vapor, down to near the absolute zero, and by that you can bring the atoms to almost stand still and into a quantum regime. Cloud of atoms is at the center, is the center dot that you can see on the camera, and if I block one of the laser beams, the center dot will disappear, as it has now, and now I unblock one of the laser beams and it will recover slowly. There it is. Then, by exploiting the quantum properties of these atoms, ultra-precise measurements can be performed on accelerations and external forces, which it's very interesting because we could then improve the state of the art of measurements on accelerations and forces by a few orders of magnitude with respect to the current state of the art.
Why is there a need for the Cohesion waveguide within your system?
So for RAL Space, SNORQL is a step in our aim to bring cold atom-based experiments to a technology readiness level that is compatible with space applications. And laser technology in the relevant part of the optical spectrum is currently one of the key components that is understood to be in need of special attention. As you can see, this setup is much more compact. It relies on telecom laser technology that has been developed for many years for space applications, and therefore is much more mature for what we want to do in space. And this is important because we can get everything in a much more compact system, more robust, and use less power.
Thanks for that. And finally, what are the next steps?
So at RAL Space, our aim is to bring up the technology readiness levels of all the components that are required for building quantum sensors. In particular, the laser systems are quite important, and we understand that they need quite a push to bring the readiness level to a place where it can be implemented into a spacecraft, and therefore we will be continuing collaborating with others into pushing this technology to a place where it can be put in a small package and that is reliable and rugged enough so that we would have confidence to put the system in a space mission.